Can I get Michelle to come up and all participants in thermal reticulations and transformational strategies? Okay, we're going to open up questions to the floor.
Is this on? So I have a question for Michelle, but perhaps it's also something that can be, I'm over here, that can be picked up by the thermal reticulations, because it's sort of to do with the relationship of real conditions to simulated conditions. So Michelle, you were talking about that working at sort of simulation at a large scale, that there's a lot of assumptions, and then you sort of propose sort of working at a micro scale, and I still wonder whether there's still not a lot of assumptions there, because it's still a representation. It's just at a very finer level, and there's always a limit to what we can simulate, because we can potentially not simulate air conditions and particles in the air or whatever it may be. And then to close, you were talking about sort of working at a human level rather than working at a building unit level, which sort of has a lot of resonance for me. But then once again the question stands, is this micro or nano level, is that really a human level?
I can go ahead and use this one. Well, I think that that's several things that are going to be tough to unpack in a few seconds. One of the things I had hoped to talk about, and I didn't quite mention, is my interest in whether or not we can use simulation for proof of concept. And if you can begin to do proof of concept by being very selective in the things that you examine. I feel very strongly that when it comes to certain physical phenomena, they have to be examined at the scale at which they occur. The question then really is that something that we should be doing within our field or within our discipline? Or can we find the types of collaborators who are capable of doing that very discrete, very directed, very detailed type of physical phenomena analysis? And then we need to find ways of how we orchestrate that, how we choreograph these different types of very deep physical analyses. I think that's the road I would like to be taken, not that everybody becomes a junior engineer and starts to simulate at this very detailed level, but that we are able to reach across and deal with those who can look at the physical phenomena at the scale at which we need to do that. Now, that said, I do think that there's many things. When we're looking at diffusion in particular in very low Rayleigh number type of fluid behavior, you do have to simulate directly at a scale that's extremely small. But there are many things, for instance, the way that we even look at how light maps onto a retina. This is fully within pretty basic capabilities of most of the things that we have. And yes, I would say, I'll disagree with you, that is human scale. That is how the neurobiological system functions. The neurobiological system doesn't function according to artifact scale. It functions according to whether in some cases micron scale, some types of submicron scale, some cases centimeter scale, but those are the interactions that we need to start thinking about in terms of what really is human scale. And it isn't 2 meters or whatever. I'm not good at metric. Whatever. I don't think I'm 2 meters, probably not. But whatever. It's not that scale. It actually is the scale at which our neurobiological system functions.
Another question from the audience?
I might comment on behalf of the thermal reticulation class as well. During the proposal, the initial idea was having 3 different scales, testing as a small scale to a medium scale, and then even go up to a room scale. That's why we were thinking about even using the thermal chamber that was here in the Butler. Then when we got into the discussion of how we scale our experiments, then it's become we all agree that we're not expert, and then we say, okay, let's not focus this as our cluster. We're going to look at compare physical and digital simulation at just one scale. So the decision was made to do the simulations in digital one-to-one, build it one-to-one, simulate exactly one-to-one. So we've just taken this scale discussion out of this equation, and then even that one-to-one scale, there's so many different factors, like the air that's moving in through the little gap of just between the facade and our box, and the air just penetrating, blasting into our room. And even those things is already far too beyond our comprehension in 4 days. So for our cluster, the aim was not to get, like I said in the presentation, the correct, this is better than this by that much. We just need to know if this is better. But with better or worse, we can't do just with our basic setup. If any, you want to comment on that?
Hold on, I'm going to run my way over there.
Hi. Oh, it's there. For the thermal reticulations group, you were exploring the analysis of actual results compared to digital results. I guess my question is, how did you, once you did that, how did you compare the two results? Or did you work on any workflow to say, you know, this is the comparison between the two? And I guess what strategies for going through that or visualizing that were you able to, you know, look at?
Maybe I start answering and then I'll pass it to Alex and Kamil. Part of this is because the sensors is measuring the air temperature behind the facade, and in the simulation we did the simulations in digital simulation, we are going down to very close to what's happening inside the material. So how we bridge that is we try to embed some sensors directly into the facade. If you went down to the exhibition, you might see one of the facade has holes drilled into them. That was Epic's facade. We embedded 3 analog sensors and record those the same time we're recording the air temperature behind it. And also we took one sensor, put externally to the facade, so right in front of the facade. And then there's lots of data points, but we haven't really able to directly compare other than the visual power view, which I showed in the video. But one thing we could do is, say, use Energy Plus, which can simulate the room environment. So we use the box as a room, and then use the average temperature of the 27 sensor as a room temperature, 1 point, and use that to correlate with the Energy Plus. But I don't think we got through Energy Plus simulation in the 4 days. But we captured all this data we can take back to Melbourne and continue working on it. And this is one of the aim, we're going to close this loop. Do you want to come in?
Yeah, I mean, I think the other thing is that we kind of didn't do apples-to-apple comparison. So in the physical simulation, we had 27 sensors, which were temperature sensors. So they were pretty much just measuring the temperature of the air. But in the digital simulation, we were just measuring the heat inside the components. So it was at the component level. And we didn't have sensors embedded in the material in the physical one. So we were pretty much gathering data, but necessarily the data was in a way not relatable in terms of apples to apples. So the types of links that we are making are pretty much done by the people that were doing the experiment. And there's links that we have not yet kind of well formed from the data that we gathered, but we have so much data that is horizontally and vertically linkable that we can now pretty much figure out once we come back in future research how to link it all together to gather some conclusions. I mean, we have some preliminary conclusions, but we wouldn't want to spoil the work by actually too early, prematurely kind of concluding on something that without not looking at the actual data that we gathered through the 4 days, which was the whole point of the experiment.
I just want to make a quick comment actually on that same topic. I think it was sometime in the last month I saw at least one court case where a client was suing an architect because decisions were made using early analysis software that all of us have played around with, but the accuracy of the actual numbers associated that were not close enough to be actually making significant decisions. Last year, we had one of the original founders of Energy Plus talking about issues of architects using early lightweight CFD analysis, energy analysis, solar analysis, and making significant decisions and trusting the numbers. And I look all the way back to the Copenhagen event when Billy Faircloth got up there and talked about her research group basically going through the early analysis of projects, afterwards doing post-occupancy analysis, same thing Judith was talking about yesterday, to allow them to start recalibrating and get a rough sense of where they are in those ranges. So just as a general comment, it's almost like when we do this early analysis work as architects and engineers, we have to put a little asterisk next to it with a disclaimer.
And just to answer a part of that Ben's question about where to start, the digital or physical, I guess in our cluster we let participants to actually first, of course, you start digital designing your model. And in terms of exploration path, like if you go into the digital workflow first or physical workflow first, it depends if you got your 3D models printed first. And and some of the models are hard to be modeled correctly, so it has to be started to be modeled by hands, and then that's why the analog testing happened first. But then this process happened in parallel, and as all my colleagues here have said, that it's very hard to make a comparison between the two, because the digital simulation is a homogeneous environment, and we can't have that homogeneous environment, as Michelle has also touched in her talk, that even if we can set up a perfect homogeneous environment in digital simulation, there's always about 30 to 40% error rate in any simulation environment. So what we actually did, we have actually a baseline model. So whatever measurement we did in a physical and a digital, we actually always compare it to the baseline model, and then we can have a sense of if this is actually performing better or not.
We've got time for one. I'm sorry, go ahead. We have one more question after this. Go ahead.
Related to your question, I think what we also were trying to do is to find hybrid methods between empirical and theoretical. So to collect data from on-site models, our mock-ups, we try to mix this with digital models. For example, in one experiment, we would measure the surface temperature of the facade and set this empirical data in our digital models as boundary conditions and try to move on from there. And with these hybrid approaches, we tried not to compare empirical and theoretical one by one, because as everyone said, it's not very possible, but to find correlations between these two towards design. So on one hand, we have mock-ups, digital mock-ups that are rough approximations of our facades, of our designs, and we can still derive much data, acquire much data about how it is going to perform in real life in full scale.
Go ahead.
I have a question for the transformational strategies cluster. I was thinking you guys are using a lot of urbanism-related performance indices. Have you thought about applying it, so changing the scale? And since we were talking earlier about scale, doing it with a volume instead of with a bigger built environment and generating an actual architectural volume, or I mean, what are you hoping is the outcome of this study?
I think the intent was to stay at the urban scale at this point. Eventually, certainly, the desire is to get to a more closer to the building. But I just listening to the preceding discussion, I think and that makes me really happy to have had the participants in the cluster that we had, that the analysis, this pre-evaluation system that they came up with, looks really at criteria that are appropriate to the scale and appropriate to the resolution of the gridded idea. And it's really, I think it really carried through. So that's your question is really great because it points to something that I strongly feel about, and at least some of the participants told me as well, that there's a feeling that there's what we produced is kind of a point in time, but that it allows to take this type of investigation much further.
I just want to add that the software we have used is capable of measuring with the high levels of disaggregation, so the point cloud structure or even being in a mesh. You can have illuminance and luminance and the visible sky window measured for each of the points of any building. And so you can assess any part of the building as to get into more detail the likely illuminance and luminance patterns for each of the rooms of those buildings. So we can get into more detail with the digital tools we have used, but we didn't have the opportunity just to show, because as Volker said, we are more concerned with the urban object that we have been dealing with.
All right, thank you.
Thank you, everyone. I greatly appreciate a round of applause for the cluster champions and for Michelle. Thank you very much.